All right, looks like we're recording everything okay and we're ready to go. Sorry it took me a little while to get started, but it's always a little bit of a mess to get things going when we're recording and sharing things all over the internet. But let's take a look at what we're doing today. Hopefully, I've started returning your homework to you so that you can kind of see how I think you're doing, and so far it looks like everybody's doing really quite well. I really like what I'm seeing so far. Let's see, can you see my screen there? Okay. But I like what I'm seeing so far in the assignments that I've graded, so keep it up. And I'll continue to try and give as much feedback as I possibly can. We're now into our 5th week, I think it's our 5th week now. Moving right through, we're about a third of the way done. And we're going to start doing visualization stuff today, essentially making graphs and charts and changing imagery with MATLAB. And we'll use that quite a bit as we move forward as well. We'll go from here, after we're finished with this, we'll move on to what we call functions, and building functions and building our own user-defined functions, as they call them. And this is really where we begin to build scripts or M files in MATLAB that are designed to do something other than just calculate something or manipulate a matrix. So far we've just been learning the syntax and the basics of this MATLAB program, but now we're going to actually start making it do things. We're going to start making it graph things for us, and then build functions that accept inputs and give us some kind of an output. And what we're working towards here in the end is being able to write a program that asks the user something or accepts some kind of user input and does something, and then gives us a visualization and some kind of output and has some interaction with it, so that it's more like the programs that we're used to in computers today. When you jump on your computer today, it asks for a username, it asks for a password. You take those usernames and passwords and checks them against the things in the computer. And that is all part of a user interface that is written by some programmer at some point, and usually by several thousands of programmers over the years. But we want to be able to do those kinds of things at a very simple level at first, and get more and more complex as we go, so that by the end of the class we can actually write a program that has some kind of use, some kind of function to it, and then we're well on our way to becoming bona fide programmers. So, plotting today, we're going to learn how to do plotting, graphing, charting of data. And of course, when you're doing something like this, you need to start with data. Remember that when we're doing our work in this class, we want to start off by opening up some kind of a script, some kind of an M file, and starting with taking notes in this of what we're doing today. So I'm going to put some text up here. This is my week 5 M file, for example, and I might put in something like plots, graphs, charts, images, just to give you an idea of what we're doing in this one. Remember that this needs to be turned in at the beginning of each week in the homework assignment, and that I will have a homework assignment for week 5 posted up later today, tomorrow morning at the latest. I'm going to try to get it done today, but we'll see how it gets finished up. But anyway, here is my M file for week 5. We want to start off here. Put your name at the top as well. That's something that I've seen quite a few of you forget to do. Just put your name at the top of your M files. You should comment in your name and maybe the date as well. This is whatever this date is, 2/10 or something like that. 2/12, what is it? Yeah, 10th. So maybe put the date and your name up there, just so you can keep track of things. Always a good idea. Also remember that we have our tips and tricks document When you learn something in MATLAB, every week you should take one thing that you've learned in MATLAB and go check the document that's on Google Docs to see if anybody has entered that. We have quite a few people who have done their homework but not entered anything into our tips and tricks document. So make sure you make your entries. If you haven't made your entries for previous weeks, make them now. Get caught up on that and get also on with the homework. If you're behind on the homework, we have a couple of people who have missed an assignment or two. If you're behind on the homework, get in there and get it done. You can still go back and do things late. You might lose a few points for that, but most likely I'll just grade it when I get a chance, and we'll just move on with it. I'm not here to try and be some kind of a control freak with your homework, and I know that this is kind of an interesting format for our class, so that we're not always teaching the same people all the time, and we're not always live teaching. Sometimes we're watching videos later. So get things done, get caught up, and get those homeworks turned in. The Blackboard should allow you to turn them in late. If you have any problems with that, please give me a call, send me an email. So moving on with today, we're going to start with some very basic plotting. And to plot things in MATLAB, you need some numbers. We need some data, some information to plot, some actual, MATLAB just needs to know what you're trying to do. And so we're going to start with a very simple set of numbers. We'll start with a set of numbers that we'll call time. We'll call time T-I-M-E, right? And time will let equal an array of numbers from, let's say, 0 to, let's go to 18, and let's go by steps of 2. So 0 by steps of 2 to 18. Go ahead and put that array into MATLAB, into our little worksheet here, our little script file. That will be time, and I don't necessarily want to see this print out to the screen, so I'm going to put a semicolon in there. And let's have distance, maybe. We'll call it distance. Might as well give it a name that makes sense to us. And our distances for these different times, we're also going to have an array of numbers, but we need to know how many we're going to have. So it's sometimes a good idea to figure out how many numbers you have between 0 and 18 in steps of 2. It's not always obvious when you type it in here, so let's go ahead and copy that and put it in our command window and see how many it is. Paste it in here and let it run. You can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers, and if we could also, if we had a much longer array or a much bigger array, we could also type in the command length and put in time in here, because time is now in our workspace, so MATLAB knows all about it, and it'll tell us that there are 10 members of the array, or 10 entries in the array time. So we're going to need 10 distances. So let's go ahead and put in 10 distances. Let's say for time 0, we're going to have a distance of 0, and then we'll just choose some distances here. I'm going to try to make these distances a little bit bigger for everyone here, for every entry. And so it's like something that is moving forward. So I think that's 10. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 distances in our distance array here, and I'm going to move this out of my way. Now we've got two arrays that we're going to use to do our plotting with, and both of the arrays have a name, and the plot function in MATLAB is really quite a simple one. You can just type in plot, and you can put in two different things. The first thing will be the thing that it puts on the x-axis. So if we put in time on the x-axis, we put that in first. And then if we want distance in second, remember to spell it the same way we did with the capital D there. Plot time distance. And at this point, we should be ready to go. We can go ahead and run this. We should run and save it, so I'm going to hit F5, and that will save it. And I'm going to save this as Jared Daily, week 5, or whatever, called Jared W5, save it in there. And then it's going to run it. And as it runs it, it doesn't print anything to the screen except the name of the file down here, but it does print this nice chart of my data. Notice that the chart is very simple. It just has the points that I entered in from 0 to 18 on the x-axis, and then it has a y-axis that goes from 0 to 18 because my biggest number was 17, and it has all these points that it plotted in between. It didn't put anything, it didn't label the axes at all. It just kind of put this in here. However, if I wanted to change things like this, I could. If I wanted to put in labels, I could. If I wanted to change colors, I could. If I wanted to have a grid, like a graph grid in here, I could do that. And it's not even all that hard in MATLAB. We can go down here and we can use a command called xlabel. And if I put xlabel, and inside of the argument I put a single quote, and I put, for the xlabel I want time, and I want to use capital letters, that's fine, I can do that, xlabel time. And I can do ylabel as well, and it'll label the y-axis. And what this does is it labels the x and y-axis of the previous plot that I've just put in here. And you can even do a z-label. So if I do z-label distance, or y-label distance, and I can even tell it what the units are. Let's say the distance is in feet. I can put that in here as long as I put it inside the quotes. And the time can be in seconds. As long as I put it in quotes, it's fine, inside the quotes. And I can go ahead and use the command grid, and then I just put a space and I type on. So I can put a grid in there as well. And then I go ahead and rerun this, save it and rerun it. And it puts in a grid, it puts in an X label and a Y label on each one of these, and we're good to go. There are other things that you can do from right inside the plot window. For example, I can select different things in the plot window by going here to my little selection tool. Maybe not my... Let's do this again. Hold on just a second. I opened something I didn't want to open. There we go. I can actually go, this is my select tool up here. It's this little plus sign over the graph. And I can select actually part of the graph. I'm hoping that it's going to let me do this. It's not apparently going to let me do that. Well, let's go ahead and pick a color first and then we'll select. There we go. Come on now. Select a part of the graph. So anyway, I can go to any part in the graph actually, and I can put this cursor on it. And it'll show me different points that are on the graph, and this gives me a range here. And I can actually, so right now I've selected 3 points. Now I've selected 4 points, and it's actually highlighted that part of the graph. And actually, I can actually go up here and I can start to change things on the graph if I select them. If I go up here and change, I used to be able to do that. Why can't I do it now? I was just doing this last night. Why won't it let me do it from here? Well, anyway, it'll let me highlight them anyway. And you can actually change colors and do all kinds of things on this graph if you want to. It's not always letting me. This feature here is just letting me rotate the graph, and it shows that MATLAB has the ability to graph in 3 dimensions. So this line that I'm doing is only in 2 dimensions, but I can rotate it into 3 dimensions if it is a 3-dimensional graph, and then I can go back to where it was originally at. You can move around on the graph so that you're only seeing different parts of it. You can zoom in on the graph and see just a particular part of it. Lots of different things. You can even start to do, go away, zoom bar, there we go. You can even do things like linking the variables to different things. So you can take the variables that are inside this graph and link them into another file or another function. Lots of things you can do. One of the very important things that you can do with this graph is you can actually save this graph, and you can save it as a figure, or a bitmap, or a JPEG, which is just like an image you would get off a camera, or a PDF document, or a TIFF document. And in this way, you can actually export this graph into different things. And this can be very useful when you're writing papers about mathematics or science. So let's say that I just do this as my distance versus time, and I save it as a JPEG. I'm going to go ahead and save it in my pictures here. And I go ahead and save that now, and I'm going to go over to Microsoft Word, and I'm going to start writing a paper that I have to write for my science class. And I made this graph that I want to insert into here, and I just go to Picture, insert a picture here, go to my picture from File, go to my Pictures, go to my distance versus time, and it imports this graph into here very nicely. If I don't like that stuff at the top, I can always go in and crop that off, just like any old picture, because it's just a normal image that I've brought into this. And it's a very nice way to bring in graphs of things, especially when we start getting into three-dimensional graphing. It can be a very nice tool for that. Let's see what other tools we have here. This one is we've obviously inserted a little legend here, and I can actually move that around if I bring my hand in here. Let's see, I used to be able to. I think I have to select it first. There we go. I can select this legend and I can move it around. So if it's in the way of your graph, you can move it down here, and it shows you that this blue line is distance versus time. What else can we do here? Of course, we can print it off. Anyway, let's that is the simplest plot you can do, essentially, is a little line plot like that. And it's pretty easy to do just by typing in this stuff here. It's actually even easier to plot things if you go to this little plots bar that we have up here. If we want to plot, say, for example, the distance, we can go ahead and just plot the distance, and we can put it in here as a bar graph. So this shows me that the first element in my distance array has a value of 0. The second element has this higher value and a higher value and a higher value, and so on and so forth. And that is very useful, of course. Again, you can put in all the stuff like we've done before here. But all we did was click on something. Just click on this, and we can make a plot of the time. The time is very simple. But if we want to make a plot of the distance and time, of course, we're going to have to select both of them. So we select the distance, and then we're going to hold down our Shift key and select the time. And then we can actually start to plot things like we've seen before. Now this one actually has us in time versus distance, right? We have time on this axis and distance on this axis because of the order in which I click them. However, if I do this distance, let's see, I think it's by order. Let me check that. There we go. So if I do time then distance, then it gives me time on the x-axis and distance on the y-axis. So the order in which you click them, the first one will be your x-axis, the second will be your y-axis. Just like we did before. Here we did time first and then distance. If you click on time first and then distance, then you'll be in good shape. Under the plots bar here, once you've clicked on something to plot, you have all these different plots. So there we go. So if you click on the little bar on the right, it brings up all the different plots that are possible, which are quite a few actually. There's one that's kind of interesting I'll show you here, and that's this one right here, the comet plot. Go back up here, and let's do the comet plot. We don't want to do it that one. We want to do it for time, shift distance, and do a comet plot. And essentially what that does is it shows you how it happened. It goes quickly through it in this case, but it goes element by element and point by point and plots it kind of live. It's like an animation, which is also very useful for lots of different things, especially when you're trying to illustrate to somebody how something happens in time. And the more points you have, the slower it goes. And so let's illustrate that really quick. Let's go from 0 to 18 in steps of, let's go from 0 to 180. And let's do 180 points. And let's go from 0 to 180 here as well. So we're just going to have two different arrays that have the same array of numbers in them, essentially. And let's go ahead and put those in. So that's just going to look like this straight line going straight up like that. But instead of doing that one, let's do this one, time, and let's do the comet plot and see how it goes. So you see this thing shoots up and it takes time to graph it out. So you can really show people how something evolves. This is a very simple thing, just a straight line. But if it's a curve or some kind of three-dimensional array, it can get really interesting to show how something evolves and to see how it evolves. Okay, so what's another thing that we can do with plots? Another thing we can do is we can add a title to it. So if I go down here to go up here to my script up here and I add a title to it, and I can put that right on the same line as the plot, or I can put it underneath that line, the next line down. Title. And then inside of parentheses, I put in the title in quotes. So the title is in quotes because it is a string, it's a set of strings, or an array of letters, in other words. So let's call this moving car or something like this. Put it inside of quotes inside this. Then I go ahead and run this. Doesn't like that. What did I do? Oh, that's right. Because if I want to do this, I have to separate this one by a comma. So now I should be able to do that. Okay. So now let's put the title up at the top of the graph, and that can be also helpful. You can even put in subtitles, and you can put in you can put in all kinds of things. There's lots of different things that you can do with plot. How do you find out how many different things you can do with plot? Well, you go down here to your command window, and first of all, I'm going to do a close all, which is going to close all my plots. And then I'm going to search help plot and figure out all the things that can be done with plot, right? So lots of different things you can do with the plot, lots of different ways you can plot things. And down here at the bottom, I can even open up the help browser document and learn lots more. Lots of things that you can do. And lots of different plots you can make. You can see here, we've got plot X, plot YY, plot 3, log, semilog X, semilog Y, error bar F, easy plot 3. Lots of different things you can do when you're plotting data in MATLAB. So, I'm going to go ahead and run this file up here again and see what we've got. We've got this plot now. One thing that I like to do when I'm running MATLAB files, I don't like to have these windows all over the place. There's this little button over here that has this little arrow on it, and if you push that button, it actually docks the figure into your MATLAB overall window here. So it puts it all in here. Now I've got my editor and my figure here, and I don't really like the way that's set up. I'm most likely going to want a different way to look at this, so I can go over here to my view, and I can look at some different options for viewing these different things. And so what I'm going to do is I'm going to make a view that has maybe 6 different spots for things. And I'm going to put, no, that's not what I wanted to do. There we go. That's better. Anyway, the view essentially allows me to split things up. And what I've done here is I've actually split it in a way I didn't want to. I'm going to close out my figure and go back to this. I'm going to run this again, F5, and then I'm going to dock it again. So I'm going to put it in here. Then I'm going to click up here, or click down here in my command window. And I'm going to go back to view, and I'm going to try, what I'm going to try to do is make I'm going to try to make a place for this figure in my overall window here. And that's not a bad place for it. I think I might prefer it. Let's see if I can remember how to do this in this new program. I think that I can grab it somehow here and put it down here. There we go. So I can actually put it down here with my command window. There we go. And you can rearrange all of these windows in some ways. There's different little buttons in here that allow you to arrange things to give yourself more room. So let's say I don't need so much room over here in my workspace, but I want a little bit more room over here so I can keep this figure down here. Or if I want to put this figure back up where I found it, I can go ahead. That's not what I wanted to do. I can go ahead and grab it. How did I grab it before? There we go. Put it back up here. So I can have it in my window with everything else. And sometimes that's really nice to have that figure right up here. And anytime you build another figure, it'll go ahead and put it in there again. So if I went into here and clicked on my time and my distance again and wanted to make that comet plot again, it would put another figure up in this spot, which is kind of nice. And if I go down to my command window and close, what it's going to do is it's going to close all those figures out. And I can go ahead and remove that window if I want to. So, ways that you can kind of keep track of figures. If you just keep opening them up by just running some kind of script file, usually it's going to open them up into their own window, and then you kind of lose track of them and you have lots and lots of these things floating around. On my Mac, it's kind of easy to separate them all using just the separate windows button or whatever they call that, and then go to them. On Windows, you can do the same thing by doing Control Tab, I think it is, or Alt Tab or something like that. You can sift through all the windows you've got open. But still, it can be kind of confusing to keep those windows open, so I like to dock them in my overall window here. Okay, so now let's go ahead and take a look at let's look at an interesting thing that we can do with plots. Let's go down here. So far I've got this plot here that's all about, time and distance. I'm going to go ahead and put in a little pause in here. And I'm actually going to start a new plot. I'm going to start a new plot that has x equal to, let's go between 0 in steps of, let's do about 100 of these. So let's do pi divided by 100, steps of pi divided by 100, right? And we're going to go all the way up to 2 times pi. And MATLAB can handle that kind of an expression, no problem. We'll go ahead and make sure that doesn't print. But then we want our y on this plot to be equal to the cosine of our x. Very simple like that. So the cosine of x is going to be our y, and the x is going to be between 0 and 2 pi. We'll go ahead and just plot this. We'll plot x comma y and see what we get. Not very good at holding my shift button down apparently. And if we run that, of course, we're going to have to go through our first plot. But I'll go ahead and just copy that down, put it down in my command window and see what we get. So there is a cosine curve. And if we turn grid on here and go back to this, we'll see that it's turned the grid onto that plot. And that's great. We can see that this is the 0 point and the cosine does what it does. And superb. That's fantastic. We love it. However, what if I wanted to plot, instead of x, y, maybe I plot 4 times x and y. I don't even know if it'll let me do this. Let's try it out. Oops, I did the wrong thing there. So 4 times x and y looks like it didn't like it. Let's see. Or did it? Trying to see if it did like it. Yes, it did like it. Because instead of plotting between 0 and 2 pi, it's plotting between 0 and 4 times pi. 4 times 2 pi, which is 8 pi. And what is 8 times pi? Well, 8 times pi is 8 times 3.14, which is just a little bit over 25. And so we're going from 0 to 25. You can see that we've got both of those there. Now, let's take this command, my plot 4 times xy. Let's copy it and let's put it into our thing here, plot 4 times xy. But in between these, let's say that I want to plot them together. And let's put a hold on this. Let's put a hold in here and see what that does for us. So let's copy all this and do this command. In the command window, current plot held. Let's take a look and see what happens. What it did is it plotted the first one and then it kept it on the plot window. So it held it on the plot window. Then it plotted the second one, and now we've got them both plotted together. So the hold command takes whatever you've put into the plot window and freezes it there, and so that something else can be written over the top of it. And let's say that we wanted to know what this would look like if we took this one right here and we went all the way to 8 pi, just like we did with the other one. Let's go from, we're going from x equals 0 to 2 pi for this one. And for this one, instead of going 4 times x, let's actually just go, let's do a different variable. Let's define a new variable, x1. So let's put in an x1 that's going to look a lot like this line. So I'm just going to copy it and paste it here. But instead of going from 0 to 2 pi, I'm going to go from 0 to 8 pi. Actually, I'm going to do that for both of these. For this one here, x1. And this one is going to be x. You'll see what's going to happen in just a second as soon as I figure this out. Kind of making this one up as I go. I try to have a set of things that I'm going to do, but sometimes I like to deviate a little bit, so I'm going to deviate a little bit and see what happens. Undefined variable or functions, because I didn't call this one x1, so let's call this one x1. So now we've got it correctly, hopefully correctly defined. Paste it in here, hit enter. And we have a problem because what I've done here is I've tried to plot x1 and y, where x1 goes from 0 to 8 pi in steps of from 0 to 100, and this one is only from, this one is only x1, so we got to be very careful with that. So we're going to have a new x and a new y. So it's going to have to be y1, this will have to be x1. So let's do this one as y. So I'm just making a new array that has the same number of data points in it because this one with cosine of x only had 100 points in it, whereas or 101 points, whereas the other one had a lot more in it. So this one's going to be cosine of x. Hopefully will be here. Okay. Oops, I did the wrong thing again. So let's go look at our plot here. So what this one did is, what this one is showing us is that the plots overlap. So the first plot goes from the 0 to the 2 pi. The second plot goes from 0 to 25 pi, but essentially they're the same thing. Right? But they overlap right on top of each other, so one overwrites the other one. Let's take a look at let's close that again. Let's look at a new plot that we can do here. A new overlapping plot, hopefully. Yeah, let's look at this one. This is a good one. So this is actually going to be fairly similar. I'm going to put a pause in here so that we have some space in here. And I'm going to actually clear all my variables. I'll do that down here too. This clears everything out of the workspace. So when I clear everything out of my workspace, I can use X's and Y's for different things again because they're not being used again. They're available. And let's go let's do a very similar thing to as we did before, actually. Let's go ahead and do this one here. Let's copy that down here. But then let's have a y2. Let's do a y2 equals sine of x. And let's prevent that from printing. And let's do a y3 equals tangent x. Prevent that from printing. And let's put a hold here. And let's put a hold here. And let's see what that does for us. Hopefully that works for us. It's not working for us. Let's go figure out why. So X has numbers in it. That's good. Y has numbers in it. Also good. So why don't we have anything in here? Oh, because we didn't plot it. Now let's actually plot it. So y equals this, and let's plot x comma y. Let's copy that. Put this down here, paste x comma y1. Let's do it again here, paste x comma y2. And that's what we want to do. We want to plot all these things. So that's now going to hopefully work. Okay. Oh, so we actually have a mistake here because we called it y2, not y1. So let's call y2 and y3. Just a little bit of debugging our program as we make little mistakes here and there. Copy, put that in here. All right, so now hopefully we've got what we're looking for. Well, we've got something here. I'm not sure what it is that we're looking at, but cosine of x, sine of x, y3 is the tangent of x, right? X, y3. So apparently something is going funny. Let's actually just do this first part and see what happens. See if we get what we're looking for there. We do not. We actually are getting a series. We get two what we call delta functions, which is not what we want. So let's close that. 0 pi, 2 pi, cosine of x, xy, 201 points. Come on, I want to demonstrate this and it's not working for me. There we go. So that's what I was looking for. Apparently there was something being held over in my workspace there that wasn't happy. So let's try this again. Okay. Yeah, it's still doing the delta function thing. Why is that? Y2 is sine x. Okay, I don't know why, but it's not going to plot them all together, even though it should. So let's not try to do them all together. Let's just do two of them together. Let's see if that works for us. There we go. So here we have two different things plotted right on top of each other. And they're in different colors. They choose them for different colors, and that's actually done in MATLAB has an order of colors that it chooses, and you just go through all these colors, but you can actually choose the colors. We'll learn how to do that in a minute. But what if we wanted to do this in a slightly more slightly faster way? We can actually do it in a faster way, and this is how we do it. We do plot x comma y, and then you can do another comma, x comma y2 or y1, for example. It knows, and it actually tells you this as you're going through, as you're typing it in. As I type this in, x comma, well, it was showing me y2. But it knows that when you put in more than two things, more than two variables into the plot command, and two of those variables are the same, in other words, the x and the x are the same, it knows to just keep plotting on top of it. So you can hopefully do lots of these things in a row. Let's try to do the y3 one. So I do a comma x, comma, let's see, did y3 ever get it? Y3 is entered, so y3, let's see if it'll do it this way. Maybe it will, maybe it won't. I'm starting to think it just doesn't like the tangent function, and that's fine too. So if we go back up here to this one, you can do multiple plots on top of each other. And in fact, we can make an array of plots, lots and lots and lots of plots. So let's see how we can do this here. I got to come up with a good one here. So let's actually make just a bunch of different functions here that are sines and cosines together. So apparently the tangent, it's not liking that because the tangent does have an infinity, so we probably need to only graph it between two different points that don't go to infinity. But if we go from for y3 instead of cosine x, we do let's say we do 5 times the cosine of x. 5 times cosine x here for this one. We call that y3. And we enter in a bunch of these. Do y4 equals 4 times the cosine of x. And we do y6 equals 3 times the cosine of x. Dang it. I've got the caps lock on somehow. Cosine 3 times the cosine, there we go, of x. And you can even make some crazier ones. And we want to make sure we comment these all out so that we don't get a bunch of stuff printed to the screen. And we'll make sure that it's not capital. Let's do a y8 equals, we can do 3 sine of x. Then we could also multiply the x times 4 or something like this. And you get a bunch of these different things in here. We've got 2, 3, 4, 6. We should do a 5 and a 7. But anyway, we can plot all of these versus x. Just putting them in, right? X and y4. And x and y6. And x and y8. And just keep going and keep going. Which ones don't we have? We need to put these ones in, I suppose. All right, so apparently we missed something here. What did we do? Up here, x times 4 is not going to allow us to do that. We need to have 4. I think we can do it this way. I think we can do 4 times x. Oh, this is the problem. It needs to be 3 times x here. That was the problem. So then we go to our figure. And we can see that we've got all kinds of these things stacked on top of each other now, and every one a different color. Right? And you can do this ad nauseum, really. You can get really interesting things when you start to add these different sine waves together in complex ways. Let me see if I can find one for you. Actually, let's do something else before we do that. Let's actually do one more thing here. Let's create an array of arrays. I don't think we've done that yet in this class. And then let's plot it. So what we've got up here, y, y2, y3, y4, y6, y8, they're all arrays. They're all, let's see, this one is 201 elements long. So they've all got 201 elements in their array. But I can actually create an array of arrays that I just call, let's call it capital Y, for example. So capital Y is going to be an array. And I'm going to make an array of these arrays. So the first one is going to be Y. That's my first element in my array of arrays. And then I'm going to have Y2 as my second one. And then I'll have Y3 as my third one. And then Y4, and then Y6, and then Y8. So I've got this array of 1, 2, 3, 4, 5, 6 arrays. Right? I can actually create now a chart of this array of arrays. And oops, I didn't mean to print that out. Let's not print that out. Put that on there. So now that I've made an array of arrays, let's put that in our sheet here. Copy, put that in here, paste, comment line, array of arrays, right? And remember that when you're turning in your notes for class, you should be commenting along here. I don't always put in comments while I'm demonstrating these things because I'm too busy trying to figure out what to type next. But we can actually make a plot of this array of arrays by using X for our first thing and capital Y for our second thing. Let's go ahead and put that in here into our command window. Okay, let's see here. Why doesn't it like that? Oh, that's because I did something wrong when I built this array. This array needs to be in column form. So we put in these things here, right? Now let's try it. I think it'll let us do this. There we go. So now it's allowed us to do this all just by having one X and a bunch of Ys. But the trick is that MATLAB wants this to be done in proper mathematical form. And in proper mathematical form, you have to have your row array or your row vector X and column vectors Y. And so you have to put these in this particular way. So anyway, that is another, essentially what you get when you've made this Y array now, is if we look at it over here, this is a 6 by 201 double, so that 201 is the same as the X, 1 by 201, and 6 by 201. The 6 doesn't matter, but both of their number of columns is the same. Right? They both have the same number of columns. And that is what needs to be done. That's the important thing. Same number of arrays, same number of columns in both arrays, and you can plot them. Okay, now let's look at something else here. Here's an interesting thing for plotting. The peaks function. What is the peaks function? Let's do peaks 10. All right. Let's do help peaks really quick so we know what we're doing here. So this is the peaks function right here, and it's kind of it's a weird looking function. It's got all these exponents in it. But in the end, what it really is a bunch of sines and cosines together that are actually in 3 dimensions. It's actually kind of a 3-dimensional array. So you'll notice in here that there are X's and that there are Y's. And if you just type in the peaks function in here, it gives you peaks function with 10 points, 10 values in the points. And if you go to your graph, it'll actually graph it for you in 3 dimensions. So now we get to see our first 3-dimensional graph. You notice that there are 2 peaks, but there's only 10 squares on each side. Very, very few squares on each side, so it's kind of a rough graph. And this is an example, a function that is just put into MATLAB to give us an idea of how this works, but it is used quite a bit, actually, in mathematics and in science. If I do 100, peaks function of 100, you can see that I get a much finer resolution. Because now between -3 and 3, I have 100 points that I'm going to use, and I can even do finer resolutions. And this is where we really start to see the tools come to life and the 3-dimensional qualities in MATLAB come to life. You're seeing that we've got these peaks, both positive and negative, and of course this is actually where the MATLAB little symbol comes from, is from this idea here. So the peaks function is an interesting function, and if you actually create this with, let's actually say, let's call A equals peaks with 100 points. So now we have assigned A these values that come out of this function, and it's a whole bunch of numbers essentially. But let's say that I want to use now this A, I want to plot A against some numbers in the X dimension, right? So we know that X goes from, we know that the peaks function goes from 0, or from -3 to 3 with 100 points in between. So let's go ahead and make, let's see, this, let's take a look at this thing. It's 100 by 100 double. That's right. So let's go down here and let's make an array of numbers from, let's call it X, big X. Let's go from 0, no, let's go from -3 with, let's actually make linspace. Let's use linspace. Remember the linspace? Linspace allowed us to make a linear space of numbers between 2 points. And let's go from -3 to 3 with 100 points. And I think that's how we use linspace. If not, we'll figure it out soon. So big X apparently is a 1 by 100 double, so that's great. So now let's actually plot X, big X, with A. And let's see what happens. Now you can see that we get a very different picture. We're actually only seeing the side of A. This is a 2-dimensional representation now of that peaks function that we were seeing. This 2-dimensional function, this 2-dimensional representation, doesn't have any 3 dimensions to it. If you turn it on its side, it will become flat. So we're essentially just seeing a cutaway vision of this thing. So really, you have to be really aware of what you're doing with MATLAB when you're plotting. You have to be aware of what data MATLAB is going to take out and plot and make something of. Otherwise, you can kind of get a little bit confused, a little bit lost. Okay, so now let's actually get into changing the graphs a little bit using some MATLAB functions. Let's go down here. Let's actually start let's go back to our original plot here at the very beginning. Time and distance. With our grid on, we'll copy that in here. Let's go down here and let's close everything. And let's clear everything. And let's clear out our command window really quick. And then let's go ahead and paste in our original stuff here, which was very simple, and we didn't want it to be that simple. Let's go back to our distances that were Um, Let's create a distance array. I believe our original thing was 0 from 0 to 10 in 2 to 18, there we go. That gave us 10 different numbers or something like that. And if we go from, we have 0 and we have 2 and we have 3.4 and we have 3.8, 3.7 and 4 and 6 and 7 and 3 are 7.5 and 8.1. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more, and 9.8. So there we go. We're good there. Let's go ahead and hit enter on that. And then we take a look at our graph. So we've got this distance versus time graph of our moving car that we started off with. What if we wanted to start changing some things around here? Let's say, for example, that we wanted to change the color. All right, if I want to change this color, what I need to do is I need to go to my plot here. Go ahead and copy that and put it back down here, paste it in here. I need to change the color by putting in a little color command here. In the color command, it goes in by putting a comma after I've entered in everything. And then I'm going to put in a quote, and I'm going to put in this dash, which is just the middle of the thing that's right up next to your 0, to the right of your 0 on your keyboard, just a dash. And then I'm going to put in the single color B, or the single letter B, and that letter B is going to be for black. And then I'm going to hit enter, and we're going to see what that does. Hopefully it did what I thought it was going to do. No, it didn't do black, it did blue. So that's blue. If I want to do black, I actually think it's K, now that I'm thinking about it. I go to K, and I hit return, and I can go up here, and it gives me black. And there are different colors that are available to you. And I can't remember what they all are, of course, but I believe that you can find them if we go into help plot. Here we go. So we've got, they're showing G, which is going to be green, I believe. K for black. B for blue, probably Y for yellow. You can essentially just kind of try them out. Excuse me. Or you can go to your document plot and you can start to see what they've got in here. So if you go here to examples and how to for plotting basics, change tick marks and tick labels, axes. No, apparently that's not the one we want. If we go to formatting and annotation, maybe. Color maps. Maybe it's in here. I don't know where they put it now. They've got so many different things in these new versions of MATLAB. Sometimes it's very difficult to figure out where to find the help. Well, that's okay. Let's just search. Change plot color. Right? So changing plot colors. Go into here and you find that you got these different things we can use here. Really? They used to have a list of the colors, but I'm not seeing it anymore. But you can just kind of play around with it. I was looking for that list of colors. Here you can see them using a couple of the different colors. But, oh, here we go. There we go. This is the list of colors. So if we come down, here we go. List of colors. Y for yellow, M for magenta, C for cyan, R for red, G for green, blue, B, white. I don't know why you would use white unless you had something else. But anyway, and then K for black. You have all these colors that you can use, but you also have different shapes you can use. Oh, and here's another one here. So if you're plotting points, you can use circles, plus signs, asterisks. You can use all these things on the graph, including some pentagrams and hexagrams. And these are the things that you type in there to do it. And again, you can use the lines. So you have line styles. The line that we used was the dash, and that's a solid line. You put that right before the color, and it gives you the dash. However, if you put two of them, then you get a dashed line. If you put your colon, you get a dotted line. If you put a dash and a point, then you get a dash line. Dash dot line. There we go. I can speak. But anyway, you've got lots of different things that you can plug in with those colors right into the arguments of the plot. And again, in MATLAB, there are several different ways to do things. You can always have different commands to do things, and it's just a matter of preference. But let's go back and use some of these now. For example, let's go back to our previous plot, which is this one with the dashed line, and let's actually put it as a dotted line. If I put it as a dotted line, I want to use the colon marker here and hit enter. Go look at my plot. You can see that I've got a dotted line. If I wanted to use a dash dot line, there we go, I put the dash and period, and I go ahead and hit enter, and it gives me, and I'm going to go ahead and dock this thing so I can see it. And if I want to change it to yellow, I go ahead and change it to yellow, but let's not change it to yellow because it's hard to see. Let's change it to magenta. And I change it to magenta, and so on and so forth. And if you have multiple plots, then after you put in multiple plots, you put in, for example, if I wanted to plot time versus distance, and then I wanted to plot time versus distance divided by 3, or something like this, right? Then I could also put another comma in here and put in this, and I put in, let's say I didn't want a line graph, let's say I wanted stars. So I could put in stars, and then I wanted them to be black, I put in a K, and then I close that single quote, hit enter, and it puts in two sets of data, one that's a line graph with the dotted dash line, and the other one which is just a point graph with these little asterisks in there. So you can put lots of different things in and have lots of different differentiators so that it's easy to tell apart different graphs on the same chart, different lines on the same graph, however you want to say that. Okay. Excuse me. So that is your introduction to plotting. And I want to move on to some other things, but before I do, I want to take a little bit of a break. I've been talking here for an hour and 10 minutes straight. So I'll take about a 5-minute break, and then I'll come back and we'll finish up with some more advanced plotting. We now understand how to do some simple stuff. Let's do some advanced stuff and start to learn the more interesting side of plotting. I'll be back at about 1:25 or so. Okay, we're back to do some more advanced plotting. Let's see where we can go from where we've been here. Okay, so moving on to some more advanced things here. We can actually have multiple plots, and that's the thing we want to do next here. So let's build a plot. Let's build a plot, build a plot, build a plot. So let's start with an X. Let's do, we've actually got, kind of got some of the similar stuff here. Let's use some of this. So we're going to go from 0 to 2 pi. This time we're only going to do 20 steps though. I'm just going to make it a little bit easier for ourselves here. And instead of defining a y right here, we're going to do this just a little bit differently to show you a different method. And I'm going to not have any other x's or y's here. And instead of doing a plot, I'm going to do what we call a subplot. So I'm going to subplot, and I'm going to do 2, 1, 1. Well, let's go find out what subplot means. Remember to use your help function, help subplot. Subplot, there we go. And essentially, let's see if it shows a picture of it. It should somewhere. Where did it go? It doesn't really show a picture of it. That's okay. Subplot is going to create multiple plots within the window. So you're going to have subplot MNP, or 3 numbers in there with commas. And it's going to break the figure into a matrix of plots, a matrix of windows, essentially. And it's going to be m by n. So I did 2 and 1. So mine will be 2 by 1. There'll be two windows. And it's going to be 2 rows of windows, right? Because rows are first and then 1 column windows. And then the P is going to be, let's see, are you there? Did you have a question? Sorry.
No.
Okay. Right. Essentially, the P is going to tell you which window that you're going into for each plot. So I'm going to do, so my first one being the subplot, if I go back to my command window, or my rows here, subplot 211 is going to tell, it's going to tell the user or the computer, it's going to tell MATLAB which window I'm putting my next plot in. And so then I can go ahead and plot. Now, instead of having an x and a y, I'm going to plot x, and then I'm going to plot the cosine of x. I can actually put a function within the plot command. So I'm going to plot x with cosine x, or whatever. You can put in sine x, whatever you want to put in. And that's going to be my first plot, and that's great. And then I'm going to do another subplot command, and subplot this time is going to be the same for the first 2 numbers, 2, 1, because I'm using the same window. I'm plotting the same one, but I'm going to put this in the second slot now, in the second plot, or the second tiled window. And then the plot that I'm going to put in there is going to be plot x, and we can do whatever we want here as well, sine 2 times x, for example, or something like this. Make sure that you put in the correct number of parentheses, and then you're good to go. So if I go ahead and run this code and take a look at the plot, well, the plot's already here. then I get the plot of the sine of x and the plot of the sine of 2x. And they're not right on top of each other. They're in separate windows or separate little subplots. And you can do this lots of different ways. You can have we could do subplot 2 by 2, for example. And in the first slot we'd put something, and in the second slot we'd put something, and in the third slot we'd put something. And you would have a plot of, in your figure window here, you'd have essentially 4 separate plots with separate axes and separate little tiles. And they would be in a 2 by 2 matrix. So you'd have one here and one over here, and kind of like 4 little boxes. So anyway, you can do that lots of different ways. And that's a very useful thing when you're trying to compare things in your plot window. You see, when I did this, it split the top into a 2 by 2, and the bottom is still in a 2 by 1, or 2 by 1 matrix. So you can do lots of different things there. Now, let's look at a very interesting type of plot that is a bit of a challenge for most students, and that is going to be the polar plot. So if I use the array x equals, let's actually use one we've been using here. So x equals 0. Let's do, instead of pi over 20, let's do pi over 100 again. Let's get a lot of points so we get a nice clean thing here. And instead of going with a subplot this time, let's go back to defining a y. Let's let y equal sine of x again. And let's go ahead and enter those two in there. So now we have an x and a y again. Let's do a polar plot using the polar command of x and y. Now remember, when we did the plot command for x and y, we got this graph that looks kind of like this. Let's see how differently it looks when we do the polar command. We need to close all here. And do this again. There we go. So this is what my plot looks like in polar coordinates. Now, if you're not familiar with polar coordinates are very different from x and y coordinates, but they are related. This axis right here from 0 to 180 is still considered kind of like the x-axis, and this one up here is still considered kind of like the y-axis. But there's a different way of looking at this now. In polar coordinates, your first coordinate is actually how far you are away from the center, and your second coordinate is an angle around this circle. And so what we've created, instead of a wavy line, we've created this kind of oval-y shape when we've done this, because the x coordinate, the first x coordinate, which is 0, starts right here because it goes 0 distance away from the center. And then it also starts at 0 angle, or at 0 theta, because the sine of 0 is 0, so it starts here. And then as it goes further away, it gets a little bit further away from this axis as the sine of that number takes us away from it. And then it takes us around to the negative plane and takes us back here to this. And so it's a little bit confusing for people to deal with polar coordinates right at first. Let's look at something that's a little less confusing, and hopefully we can make sense of polar coordinates. So let's do the polar, let's do a polar plot of 1 for our first one, and we'll do pi for our second. No, it's actually the angle is first. It's telling me here theta is first, so that's my first is the angle. So I'll do pi divided by 2, and I'm going to do comma rho, which is the length of my line, is going to be the second one. I'm going to do that one, and that's going to be now my plot. Now it's not actually showing my plot, and I don't know why here. Let's see, it should. Let's do it off axis a little bit. Let's do pi over 3. Hit that. Why doesn't it show my, it should show a point out here. Oh, no, that's not the point. This should show a single point, and it's not for some reason. But that single point should be somewhere right in here. Actually, it should be right along this edge, where we're plotting at the point, at the point where the angle is pi over 3, which is right about here. So this is pi over 3, or 60 degrees. Actually, this is in degrees, so let's try it again in degrees really quick. Let's go ahead and 60. And 1, and take a look at our graph. Yeah, it's still not doing it. But anyway, 60 degrees and pi over 3 are the same thing. So what it should have done is it should have rotated out here to 60 degrees, and then it should have gone 1 away from here and put a point right there. And maybe the point's just too small to be seen, and I don't know why. But that's essentially what the polar plot does. So let's do something a little bit more than just plot that circle. Let's do something a little bit crazy. So let's define a thing R, which we're going to call R is going to equal. Actually, we need to define an angle. We'll define an angle. We usually use theta for an angle, but you don't have to. You can call it anything you want. We're going to use theta in this case. And we're going to define an array of numbers, theta from 0, and let's do from 0 to 2 pi, I guess. 2 times pi. Let's use linspace again. And let's go from 0 to 2 pi. And let's do it in steps. Let's do 100 of them. Why not? So that's our theta, and theta should end up being this thing that's 100 long, 1 by 100 double, and that's great. And then let's define another one, R, and R is going to equal 5 times, let's do 5 times the cosine of theta. Or let's add a little bit of, no, let's do R times, let's do 5 times the cosine of theta. That's perfect. So we've got two things here that should be 1 by 100 doubles, and they are. And then let's go ahead and make a polar plot of this. Polar plot, and we're going to do the theta first, polar plot of theta, comma R, and let's see what it gives us. And let's go ahead and dock this thing. So we see it all the time. So that's what it's given us. 5 times the cosine of theta. Remember, the sine of theta was a circle up here. The cosine of theta is over here, and this is 5 times it, which means it's 5 times as big this way. You can see that instead of going from 0 to 1 up here on this axis, it goes from 0 to 5 all the way out here. So this thing is 5 times wide. So that's pretty big. Let's change R a little bit. Let's change what R is. Instead of 5 times the cosine of theta, let's do 5 times cosine of 2 theta. And let's see what that does to our graph. See how it changes it, and we're going to plot our plot again, our polar plot. Oh, that's kind of interesting. Instead of making one circle, it made these 4 kind of leaves. You can think of them as, right? And let's change it again. Let's change, instead of 2 times theta, let's go 4 times theta and see what happens. And let's plot that. And you can see now at 4 times theta, we now have 8 of these kind of like petals on a flower, right? And there are actually lots of different things that you can do with this that are quite interesting. For example, we can define r to be 5 minus 5 times cosine theta. Let's see what that does for us when we plot it. You can see now that it's actually rotated these leaves. So the leaves have been rotated a little bit, and there's fewer of them again. And what if we did instead of 4 times theta, we just did 1 times theta. Just theta by itself, 5 minus 5 times the cosine of theta, and then we plotted that. You can see that it actually it changes the shape of this, puts a little dimple in this, these things go further over here, and it starts to be really kind of interesting. There are lots of different things that we can do with this. What if we redefine theta? Let's let theta equal, let's go from pi over 2, and let's go in steps of 4/5 times pi, and let's go all the way up to 4.5 times pi. So pi over 2 to 4.5 pi. And then we're going in steps of 4/5 pi. It's kind of an interesting thing to think about, maybe. Maybe not, but I think so. And then, let's see, let's let r, what did we have r as right now? Can't remember what r was, so let's go look at it. Our last r that we defined was r 5 minus 5 cosine of theta, right? So let's redefine r really quick. That's r equal Let's actually let r be very simple. Let's let r equal just these things. 6 1s. And then let's do a polar plot of theta and r and see what it gives us. Now this is kind of interesting. Let's see, I want to undock. There we go. So this is what this has given us. And why? Why did it give us this? We defined r as these vectors that are 1, 1, 1, 1, 1, and 1. Or these numbers that are 1, 1, 1, and 1. And then this polar plot that goes around in thetas from pi over 2. So pi over 2 is up here, 90 degrees. That's pi over 2. And then we go in steps of 4/5 pi. So if we go from pi over 2 around 4/5 pi, we actually get to this point right here. And there's a line that's drawn from here to here, because we go from this point on this one unit wide circle down to this point on this unit wide circle. And then if we go around 4/5 pi again, we get to this point, and it draws a line between this point and this point. If we go around 4/5 pi again, it takes us down around here. So that 4/5 essentially is dividing this 2 pi circle into 4/5, right? Take 4/5 and divide by pi. Why 4/5? Well, because to get around this 2 pi circle, we have to essentially go around twice and dividing this circle into not, essentially this division here is we go around twice in fifths. And so if we wanted to go around this circle once in fifths, we'd just take 2 pi and divide it by 5, and that's how far we'd go around. But to go around, to take 2 trips around, we'd have to take that angle and multiply by 2, and essentially that's the result. Instead of 2 pi divided by 5, you get 4 pi divided by 5. So that's the 4/5 pi, or 4 pi divided by 5. And so this right here is 4 pi divided by 5, and then 4 pi divided by 5. And 4 pi divided by 5 around again gets us back to where we started, essentially. So we go 4 pi divided by 5, 4 pi divided by 5, 4 pi divided by 5, 4 pi divided by 5. Takes us 2 trips around the circle to get all the way around the star, and then that connects us to this, connects all these points on this star. Now if you wanted to do a 6-pointed star, it would be a little bit different, because we would want to go around the circle in 6s. We want to go around the circle twice, and we want to split that circle into 6 twice, and so instead of 4/5 pi, you're going to end up here with 4/6 pi, right? And going from, and you can start wherever you want, and then you'll end up wherever you want. But the problem is that you have to figure out what is this 4.5 going to end up being here. Instead of 4.5, we're going to get something else, because this ending point, it doesn't end exactly where it begins. So it goes from here to here to here to here, and that is actually the ending point. And so, but anyway, the point is that you gotta be kind of careful with this last number to do this in 6s, and I'm going to leave that one for you for a homework problem. So one of your homework problems is going to be to modify this so that you can make a 6-pointed star instead of a 5-pointed star, or whatever you want to make. And it's a little bit tricky to figure that out. You kind of have to play around with it a lot to make it work, but I'll leave that for you to do in your homework. Okay, let's look at some bar graphs and pie charts. In MATLAB, it is much easier to make bar charts and pie charts and everything else nowadays because of the plots button up here. But there are commands for them. There's the bar, and let's just go ahead and do a couple of these really quick. Let's clear out some things. And let's make an array, another array, of course. We always have to have arrays because you have to have numbers to make plots. So we'll make an array, just a simple one. And let's make a Y array. We're going to just use generic letters again here. X and Y. In this one, I'm actually going to make this I'm going to make this Y array a column array. Where I'm going to put X in one column. So I'm putting this first one in this first column, and then in the second one, I'm going to put in the array of numbers between 1 and 5. So it's just a new way of doing this. And I'm going to go ahead and print that off and show you what it looks like. So it's actually first row, not first column. So you've got these two rows now, and 5 columns, 1, 2, 5, 4, 8, and 1, 2, 3, 4, 5. And now I want to make a bar chart of this. So let's go ahead and do, let's do help for a bar chart really quick. And bar XY draws the columns of an n by n matrix Y into bars, right? So I can actually do this a couple of different ways. Here it says it just uses the default values. And whenever you do this, whenever you do help in the command window, you're going to get a couple of different options. So I'm going to just do bar chart of X just to try that out and see what happens. And what it does is it takes the first column of X and puts that number into the bar chart, and the second column puts that number, and the third column in, fourth column, fifth column, and so on and so forth. And this actually is the same thing that I would get if I did bar now I have to remember what I did here. If I do bar of y, I think. No, bar of y is going to put the first row into its own set, and the second row into its own set. So it's made two different bar charts, and that can be useful. However, if I created y1, for example, and let this equal the same array of numbers, 1 to 5, like this, and then I did, let's make sure we got that. Yeah, so y is what we want it to be. And then I do bar of x comma y. The length of x much makes the length of y. What is the length of y? 2 by 5. This is 1 by 5. Oh, that's right, because that was y1, right? Forgot to put in y1. So x comma y1, there we go. Then it does the same thing that it did before, except what you're seeing here is we're actually seeing backwards. What we're seeing here is that it's actually put the values underneath here for each of these. Oh, I see what it's done. It's actually put them backwards. So it actually put the y on this axis and the x on this axis. So if I wanted to do this properly, I actually want to put them the other way. So I put the y1 first and then the x. And then I would see what I'm looking for. There we go. So that's how you do it. So essentially doing bar x and bar y1x gave me the same thing, because in the bar charts, the y actually, the first thing is the groups of these things, right? And the second thing are your values. So it's the same as a line plot or a point plot in MATLAB, where your x is the horizontal axis, or the first number is your horizontal axis, and the second number is your vertical axis. But it can be extremely confusing to people because you get the same thing if I just put bar x, because this just takes each of the columns and puts them into that figure. Each of the columns essentially acts as the one. This is column 1, column 2, column 3, column 4, column 5. In this last one, all I did was I told it that 1 was 1, the second one was 2, the third one was 3. So what is the difference? Why would we have anything different like that? Well, let's say that I wanted to put in an array called names, and let's make this an array of strings. And I call the first string I'm going to call 1, and the second string I'm going to call 2. Third string I'm going to call 3. Fourth string I'm going to call 4. Probably get the drift at this point. And the last one I call 5. So now I have these names 1, 2, 3, 4, 5, and I can go ahead and make a bar chart that on the x-axis has names, and on the y-axis has x. Oops. Let's see here. Oh, come on, give me a break. What did I do wrong? Not enough input arguments. Of course I have enough input arguments. 1, 2, 3, 4, 5. Names. Oh, that's the problem. see, change this here. Okay, so it doesn't want to use that. I have to switch to a different format here. Let's do it a different way. Let's change names into, instead of a bunch of names, instead of a bunch of strings, let's actually change it into values, just 5 different values, 12, 34, 53, 2, let's not use 2, let's use 6 and 9 or something like this. So I've got 5 values for my names thing here. And then let's go ahead and do this bar chart. And now you can hopefully see how this changes things. Because I've given values to these things, it's going to arrange them in order and then leave spaces for things that are missing. And that's why we saw the spaces on the other one when I used the Y, whatever the Y2 was or whatever. So bar charts, the bar charts in MATLAB kind of have this built-in functionality where on this axis here, if you put in numbers, you're going to have spaces to account for numbers that are missing. And that's one thing that you really have to be aware of with bar charts in MATLAB, and that's because MATLAB treats everything that you put in as a value. It knows the value of it, and so it will split things up into these things. You can do 3-dimensional bar charts. You can do 3-dimensional pie charts. You can do pie charts, any kind of pie chart you want to as well. So if we just wanted to go in here and do, if we do a pie chart, you just do pie. And again, MATLAB automatically knows how to do pie charts because of percentages. So it just builds the percentages out of each one of these things, right? And you can add labels to these and do other things just like you can in anything else. But let's see what other kinds of, we can do, we've got to hurry up here because we're running out of time. We can do histograms, just about any kind of chart you can imagine can be done in MATLAB. I'm skipping over certain charts like log plots and semi-log plots because I don't think it's relevant for this class, this level of stuff that we're doing here. So the next thing that I actually want to do is I want to move to 3-dimensional plotting. So 3-dimensional plots, we've already done an example of one. But let's go ahead and build a new set of numbers here. Let's start with x equals, let's do another linspace of numbers. Let's start at 0. And let's go to 10 times pi this time. And let's do a lot of points in between, 1,000 points or so in between. So we're creating this huge linear space of numbers, and x should now be this array, 1,000 numbers, which it is. That's good. And then I'm going to build y equals the cosine of x. So that should be another 1,000 numbers. And z, we're going to have equaling the sine of x. Another big array of numbers. 1,000 numbers in each one of these. 3D plot, we just do plot 3. And I'm just going to do x, comma, y, comma, z, and see what that does for me. The plot of x, comma, y, comma, z is actually this spirally thing. The x, your x axis is right here, from 0 to about, 31 something, 31.4. It's 10 times pi. Your y and z plots are in these dimensions, this one and this one. So your y and z, this way and this way, and when you plot those together, it creates this rotating circle. And this is exactly why the sine and the cosine function are are related to circles. If you've taken trigonometry or an algebra class that talks about a little bit of trigonometry, they talk about the unit circle. This is the unit circle as you go through numbers in pi. The unit circle is actually a three-dimensional circle. And of course, we can see that it's three dimensions by rotating it, that in every dimension you get some kind of a plot that is two-dimensional or greater, right? You can see all the dimensions of it, and so on and so forth. You can also do the comet in 3, which is kind of cool. Do an x, y, z plot of the comet. And this will show us the comet plot of this, where it traces it out a little bit at a time and shows you how it goes from beginning to end. Let's go ahead and dock these again. You can label these and grid these just like anything else, like any other plot if you want to. So that is three-dimensional line plotting. Now we can also do three-dimensional surface plotting, but it requires a little bit of legwork. And the legwork is that you have to create what is called a mesh grid. And it's not as hard as it sounds. A mesh grid is essentially an array of arrays. So, for example, if I make this grid of numbers that goes, or this array of numbers that goes from -10 by steps of 0.5 to 10, right? If I just put in this command here, oops, I forgot my colons. That's a semicolon. Put in my colon, 0, and that's not. Too big, too small of a step. So make this array of numbers. This is what it looks like. It goes from 0 to 10 in steps, from -10 to 10 in steps of half. So it's just all these numbers in this big long row and all these columns, and just a bunch of numbers, 20 numbers or something like that. I think it's going to have, and that's great. This comes under answer. It's it's actually 41 numbers, but that's fine. And if I did that twice, and then put those two rows into two columns, then that would be what we call a mesh grid. However, it's not so easy to do it by hand. It's a little bit harder to do it by hand, but we can do it using this syntax. So I'm going to do x comma y. I'm going to change. X and y are going to become different things now. And I'm going to put them in an array. So x and y are in an array. And in the place for x, I'm going to be putting in this array of numbers that I just made in answer. So I'm going to do a mesh grid, what we call a mesh grid of my answer, which is this array of numbers. And I'm going to put that in for x, and then in for y, I'm going to put in the same mesh grid, the same number, same array of numbers. So mesh grid will take whatever I put into here and put it into an array of numbers here. So it's putting it into these rows of these numbers in this grid. And let's see what that does for us. So I hit return. X now is going to be the numbers from -10 to 10, but it's not only in one row. There are 41 rows of it. You can't really see here, but if I expand this down here, I'm trying to figure out how there we go. If I expand this down here, you can see that there's 41 rows of this. And in Y, it's the same thing. There's 41 rows of this, from -10 all the way to +10. And that's what mesh grid does. Mesh grid creates an array of arrays, essentially. So now I have two arrays that have created all, where I put all these numbers in all the columns, but then I've created 41 rows of these, the same column. So I have essentially a square matrix that has 41 columns with different numbers, but 41 rows that are all the same. And the details of why this works are kind of lost in the mathematics. They're kind of lost in the linear algebra of the mathematics. But it is necessary when you're doing three-dimensional arrays. So now that we've created this array of arrays, or however you want to think of it, these two-dimensional arrays that are kind of connected to each other, then I can create a new array of numbers, z, that is going to be the sign of all the stuff that's in X. And then I'm going to, since they're both big arrays, I'm going to use the dot times function, and I'll multiply by the sign of all the stuff that's in the Y stuff, in the Y thing. And I create that big array of arrays. And then I want to go ahead and see what this is going to look like. I want to make a surface plot of this. And the surface plot function is just surf. So if I do surf of x comma y, let's see if that works for us. And it kind of does. So this is the surface plot of this sine versus the sine. Sine times the sine value. Not very exciting. Let's do a different one. Let's take one that's called the hyperbolic tangent. And let's make z equal to the hyperbolic tangent on this second one and see what that does for us. And then let's go ahead and take the surface plot. Wait a second, what are we looking at here? It's not what I was looking for. Okay, let's I think I might have these two. Still not working right. Not the one I was looking for. It might just be taking its time, but I doubt it. Usually, that's not the problem here. Let's I kind of wanted to show you this one because it's nice. It's a nice I'm actually going to type these out explicitly and see if that works better for me here. So this is negative 10 by 0.5 to 10, and this one is the same. Oh, this is the reason. Because I don't want surface of xy. I want surface of xy z. There we go. That's what I was looking for. So this is the plot of x, y, and z together when you have when you've multiplied the sine times the hyperbolic sine. And if we just do the sine times the sine, we actually will get something a little different too. Now if I do this properly, surface XYZ. So this is just the sign by the sign, which is what I was looking for the first time. And this actually turns out to be a very important structure. This particular structure is actually what is called a optical lattice. They use light like this, where they overlap two sine waves of light, and they create all these little holes, these blue parts, which are essentially traps for atoms. And they can actually trap atoms inside of lasers by overlapping lasers using this kind of a shape. And they use MATLAB to visualize that before they ever do the experiments. Let's see here. What else can we do? What time is it? We're running out of time here. We can also do some plotting in time here. Let's see if we can do one of those really quick for you. Well, I don't think we'll have time. No pun intended, but I don't think we'll have time to do a plot in time, but we can actually save that for our next class. So when you plot in time, essentially it becomes what is called an animation, and it's very similar to the comet thing, except that we would actually choose some time to create a time variable or a time array and have something run for a certain amount of time and see how it changes as the time goes by. But we will get around to that later as we learn some more stuff about MATLAB. There are a lot more things to learn about plotting, so you can learn things on your own if you'd like as you're going through and doing the homework that I will post up later today. You can change all kinds of things from inside the window. Go ahead and experiment around with it. You're not going to break it. Kind of enjoy yourself and make some functions, make some weird, do some weird stuff here and here with sines or cosines or squaring things or square rooting things. It's actually not very hard to do. I mean, you just come up here and choose the thing that your z function for in this particular case, and let's put a square root in here inside the sign. It's the square root of y cubed or something. You know, put in something kind of crazy, hit return, and then plot it again and see what happens. And you might get lucky and see something really interesting. You might get kind of unlucky and see something not very interesting. But in this case, it's not all that interesting. But you can certainly play around all you want. I will end my video here a little early and ask if there are any questions or concerns as we're going through this stuff. Do we have any questions or concerns?
No.
Okay. So a lot of that stuff that we did today, you can find in chapter 6 of the book that we've been using. They do a lot of examples in there. Some of them are just like the ones I did. Some of them are a little bit different than the ones I did. But that's the MATLAB Succinctly book. But any of the other books that I've posted also have sections on plotting and other things. They're good references, good sources. But remember, your best source is often right inside of MATLAB, the MATLAB help, or on Google. Use a YouTube video or some other site to learn how to do something. And you're always welcome to call me or email me if you have a question, and I can help you out with that. So make sure you check your homework that I've been grading and reposting. There should be comments for you to see, and use those comments to improve your programming as we go, especially as we get into more complicated stuff. And have a good week. We will see you guys next time.